a dog owner like me, you're probably familiar with this. It's called a chuck-it. It's a device that helps you throw a tennis ball further than you would normally. Let's check it out. There are two features about the chuck-it that make it able to move a ball pretty far. The first and most obvious is the length of the chuck-it, and the second is the curvature around the top. Before exploring each of these characteristics further, let's take a look at me throwing the ball in slow motion.
Notice anything? Let's take a closer look. See how the bendy part straightens out at the end?
It bends like that because of the tennis ball's rotational inertia. Inertia is an object's resistance to change in motion. Just how this heavy trash can on this dolly is really hard to start moving, it's also pretty hard to stop! The bend in the chuck-it is important because it allows the ball to build spring potential energy, along with the moving kinetic energy. Once the acceleration of the ball slows, the spring is released, giving the ball a little extra velocity. The reason the length is important is because it gives us a bigger torque or twisting force. It's very hard for me to undo this bolt with just my arm and a very short lever arm. But when I use this wrench, I'm getting a much longer lever arm and therefore more torque, and I can easily get the bolt moving. The torque generated is proportional to the length of the lever arm. Now that we know the physics behind the chuck-it, let's figure out how much faster I can throw the ball with it. Now let's do some physics.
First, I switched around the final velocity formula to solve for initial velocity. Then, using the vertical component of motion, I found the vertical velocity. Using the vertical velocity, I was able to find the overall initial velocity of the ball thrown without the chuck-it, 23.63 meters per second. Using the rotational acceleration formula, I was able to find the acceleration of the ball. Multiplying by the mass of the tennis ball, I was able to find the torque used. By dividing the lever arm, I found the force that I put in to throw the ball. Multiplying by the new lever arm gave me the torque of the arm and the chuck-it. I divided by the mass of the tennis ball to find the acceleration of the ball with the chuck-it. Knowing the acceleration in lever arm, I plugged these numbers back into the rotational acceleration formula to get the initial velocity with the chuck-it, 85.65 meters per second.
So there you have it. That's the physics behind one happy dog. Thank you.